Hello everyone, and welcome back. So now we're going to talk about rule number 1 for GD&T. Okay, rule number 1. It's technically ASME 14.5 rule number 1, but rule number 1. And what it means is this. Any dimensioned regular feature of size must have perfect form at maximum material condition. And the maximum material condition is simply when we have the most material in the feature. So there is a perfect form boundary at the maximum condition, and if it violates that, it fails. In the opposite case, though, if the feature is at the least material condition, it does not have to have perfect form. Now, what am I talking about here? Like, what does this mean? Well, what I mean is this. Like, so here is my shaft, okay? And as I designed it, there is a maximum size. So I gave it some sort of dimension, and I said, well, maybe it was 10 plus or minus 5, and so this would be the maximum size. It can't be bigger than 15. Now, as long as it's smaller than 15, well, it can vary inside of this envelope. It's allowed to. So maybe this is 10, and it's able to vary. It's got a lot of room for those errors. But as it gets bigger and bigger, it can't go outside this perfect form envelope. So it's like this is a perfect cylinder that's at the max size. So as I get bigger, I start to struggle. I don't have as much room to move around anymore. Like a caterpillar in its cocoon. And as I get bigger and bigger, I finally reach that point where once I'm almost at the maximum material size, I have to have almost perfect form. Once I'm at the maximum material size, it has to have perfect form or else it fails. Okay? So this is rule number 1. When you reach that max size, you have to have perfect form. It's got to be that exact perfect shape, because that's the only ways it can stay in that max material condition envelope. Now there are exceptions to this. It doesn't apply to stock shapes and sizes. It might be when you have an extremely long cylinder, things like that come in very, very long lengths. It just doesn't make sense. We can also have an exception invoked by applying tolerances or modifier symbols. Okay? The independency symbol is an important one here. If you add the independency symbol, which looks like this, it's an eye with a circle around it, and you put it next to a size dimension, it simply states that size dimension doesn't have to have perfect form at the max material condition. There are other places where maybe the dimension form tolerances control straightness or flatness of derived axis or derived center plane, which is simply saying we don't care about the surface, we care about the center plane, and then those would take into account the form variation. So there are a few exceptions here. Super long things that don't make sense to have perfect form because they're just super long, they're going to be changed to other things, or using this independency symbol, the ones that are going to be the biggest. Now, it does not require perfect relationships between features. So right here, you see I have two features. I have a height and I have a width. You're like, well, that's one feature, it's a rectangle. No, that's two features. The height and the width. And at max material condition, the width at all points must be 3.01. As you can see, it is. At every single cross section, it's 3.01. And at every single other position, in the vertical direction, it must be 1.51 in height. So all of these, 1.51 in height. And the top is parallel and flat, and the sides are parallel and flat, but they are not perfectly at right angles, because I didn't actually have a tolerance. Oh, that's right, there's the tolerance right there. I allowed a 5-degree tolerance. So we do not have perfect relationships, only the perfect feature itself. So these two features must be perfectly parallel. These two features must be perfectly parallel in a particular distance from each other. But the angles are not controlled. And we don't want to do that unless it's extremely necessary. We'll usually add tolerance to things to allow form variation, even when we're at the max material condition. There are places where it would be good for us to have variation. And in most cases, it's fairly simple. What we'll do is we'll say that it gets more variation as it moves away from that perfect form boundary. Because we saw that earlier, had that perfect form boundary, and I was able to vary quite a lot. And GD&T is going to give us various ways of telling it to be able to vary like that, where as we move away from that perfect form condition, we can get extra tolerance and it'll still meet its function. Now obviously, none of your tolerances are going to be that crazy. I'm having to exaggerate things as I draw. Okay, rule number 2. And it simply says that if you don't see some sort of modifier like the max material condition or the least material condition, then regardless of feature size is being applied to all tolerances. And regardless of material boundaries will be applied to all datums, unless you see something next to it, like something like that. So if you don't see that, it's regardless of material boundary, where it's just you go and you clamp down to the size it is, regardless of feature size, where you just sit it down and you don't really have any worries about what size that particular feature is, or the variation on it when you're using it as a datum or when you're measuring it to see if it's past tolerance. So I think that's everything. Yes, it is. So we learned about rule number 1 and rule number 2 today. Rule number 1, perfect form at the max material condition. And rule number 2 is simply saying that if you don't see anything, it's regardless of material boundary or regardless of feature size. So thanks for listening, and I'll see you all next time. Goodbye.